we go. We are going to start our new unit today. Unit 6. So the last unit, polynomial, expressions, equations, functions. The next many units that we do are going to be just some other type of expressions, equations, and functions. Things we're going to simplify, things we're going to solve, things we're going to graph. No, it will be fine. It will be fine.
Why did you give us the whole page to do a problem at the end?
Because you need a little more than a half a page, and just so you have plenty of room. Don't worry about that right now. That's not for today. So this unit is about radical expressions, equations, and functions. And radical is just like a fancy word for root. This unit is about roots. We already know a little bit about square roots, simplifying square roots. We're going to do some other work with square roots, adding, subtracting, multiplying, dividing, equations with them, graphing, all that. But we're also going to look at other types of roots that we're going to start with today. We're going to talk about cube roots for about half the period, and then the other half of the period will be, well, fourth roots, fifth roots, sixth roots, other types of roots, and we're going to see by the end, they're really all kind of handled in a similar way. Let me get my calculator out, and we're going to start this the same way we started our, oh my goodness. We're going to start this the same, we're going to start this the same way we started our square roots, by making a list of our first few perfect cubes. We may need a calculator for this. Oh, we're sharing? Oh my gosh. Oh my gosh. What's 2 cubed?
6, 9, 2, 4, 6.
2 cubed is 8. 2 times 2 times 2 is 8. Okay, hush. 3 cubed. That people tend to get wrong, it is not 9. It is 27. 3 cubed is 27. 4 cubed is 64. 5 cubed, 125. 6 cubed, 216. And the next really important one is 10 cubed, which is 1,000. What about cubing negatives? Negative 2 in parentheses cubed is what? 8 or negative 8? Negative 2 cubed means negative 2 times negative 2, that's 4. Times negative 2, that's negative 8. Square a negative, you get a positive. But cube a negative, you get a negative. Which is actually going to be very nice with other things in a moment. We'll get there in a bit. Negative 3 cubed, negative 27. Okay. Not super important, and if we need them, we can use the calculator to just figure out what 7 cubed is, what 8 cubed is, and those things. So cube roots undo cubes. The cube root of 8 is asking the question, what cubed gives us 8? 2. Oh, yeah, by the way, how do I know it's a cube root? That little 3 inside the root tells me it's a cube root. You put no number there, and it means it's a square root.
So how is that equal to?
Because what times itself, what number cubed gives us 8? 2. Okay, so what's the cube root of 125? 5. Now we got to be a little careful. Hands for this one. Vana, cube root of negative 64. Negative 4? What I am asking you is what cubed, what times itself gives you negative 64? I think Vana's 100% right. Negative 4, because negative 4 times negative 4 is 16. Times negative 4 is negative 64. It is negative 4. When we do square roots of negatives, we couldn't handle that, so we had to invent those new imaginary numbers to deal with that. Cube roots of negatives, we can totally do, and we just get a negative number answer for that. Okay, one more that wasn't in your packet, but I want to add in. I would like to do, actually 2 more we're going to add in. The cube root of 343. And the reason I want to add this in is because I want to show you how to do cube roots on your calculator. Were you about to ask what I just said we're going to learn? Yes, what do you know? Okay, so here's how you do this. On the graphing, I'm going to show you the graphing calculator first, then I'll show you how to do this on a scientific calculator. On the graphing calculator, if you push the math button on the left side, well, it looks like actually, those of you who were complaining that there is no cube, it actually is here under the math menu. It's option number 3 if you want to cube something rather than raise it to a power. Instead, yeah, so I wouldn't do that, but I am going to use the cube root button, which is option number 4, cube root of 343. Push enter, but don't say the answer yet. Those of you with a scientific calculator, I think you're going to have a button that looks like maybe this, maybe the X and Y are in a different place, and it's probably like a second to get to that button. And yeah, you're fine. Don't say the answer yet. I'm trying to show other people how to use their calculators because no, you have a graphing calculator. Okay, and those of you with scientific calculators, okay, hold on. If you have a scientific calculator, watch please, you do not actually have a cube root button, you have an any other type of root button. So the way we're going to have to do this is we're first going to have to tell it we're taking a cube root. You're going to type a 3, then you're going to push the button that looks like this, or looks like this, or something like that, and then you're going to say 343. Did you get a nice number? Don't say it, but... Okay. Can anyone else not find it? Nope. It's going to be second. Hold on. Oh, I guess you do know the cube root. You've got both the cube root and another root, so you don't need to do the 3. You can just do second and that button. So what is the cube root of 343? 7. And it's really easy to check that because you could just do 7, using your calculator, 7 times 7 times 7, 343. One more just to test out the calculator. Let's do the cube root of 2,197. Yeah, which is a great one for the calculator. What do you know? Yeah. 2,197, go. And the answer is 13. Okay, obviously, it's not this easy because usually, like with square roots, they're not going to be nice numbers. They're going to be kind of messy things. If we use the calculator, we get a decimal, but we want to see how to simplify these things. When we simplified our square roots, it all came down to like knowing our perfect squares and trying to break things down into a perfect square times something else. It's going to be something similar with our cube roots. Here's our process. Step number 1. And I think I'll write the process at the same time that I'm going to go do letter A on the bottom, the cube root of 16. By the way, you go to your calculator, do the cube root of 16. It's going to be a decimal. Let's actually check that. Do the cube root of 16.
4.
It's not 4. 4. Square root of 16 is 4. 2.519 and all that. Yeah, I want to get an exact simplified answer for that, so that's what we're going to look at doing. It's not a fraction. Here we go. I want to rewrite the stuff under the root as not a perfect square times something else. Instead, it's going to be a perfect cube times something else. Rewrite the stuff under the root as a perfect cube times leftovers. Rewrite the stuff under the root as a perfect cube times leftovers. Hello, just a quick attendance thing. Katie Limburner Jensen's marked present. She is not. Okay, thank you. Yep, bye. Okay, so I want to rewrite this as the cube root, and we've got to put that 3 inside there. I do not care about 4, 9, 16, 25, those things. What I care about now are these numbers, 8, 27, 64, 125, 216. Well, 16 is which of those numbers, don't think too hard, which of those numbers times something else? Leo? 8 times 2. Okay. Step number 2, I'm going to take the cube root of the perfect cube and move that outside the root. Take the cube root of the perfect cube and move that outside the root. I feel like I did some underlining when we did like square roots, so I'm going to do the same thing here. I'm going to underline that cube root of 8 because I know I can handle that one. Cube root of 8 is 2. So we're going to say 2 times the cube root of 2. I'm not going to bother writing the next step. The next step is just check to see is there anything left under the root. Definitely not, because my smallest perfect cube was 8, and this is already smaller than that. My simplified answer is 2 times the cube root of 2. If you went to the calculator and typed that in, you'd get the same decimal you got when you typed in cube root of 16, but this is the simplified exact answer that we're going to want to give for these. Anything so far? This is the beginning of class. It gets a little more involved, but if you're with me right now, you're fine. Let's try letter B. Cube root of, and this is definite, well, maybe not necessarily this one, but in general, you're going to want to use your calculator to figure out, can you divide it by 8, or 27, or 64, or... What can we divide this by? 27. We're going to say this is the cube root of 27 times 2. Well, 27 we can take the cube root of. What is the cube root of 27? 3. Your answer is 3 times the cube root of 2. Do we see what's going on? Yes. Then you try letter C. And remember, after you're done, look at that number and see, can you do anything more with it? Can you divide that answer inside the root by 8, 27, 64, 125? Bless you. Ethan, what did you find inside 320?
64 times 5.
64 will work. Did anyone use 8 instead of 64? Okay, well, I'll show you how that works in a moment. But if we do cube root of 64 times 5, cube root of 64 is 4. So I'm going to say 4 root 5. Good? What did I mess up? If you write this, it means 4 times the square root of 5, and I know it's a small thing, but yeah, I would take off a point for that on a quiz, so make sure you're telling me a cube root. You put no number there, and it means square root. When I originally did this, I only dealt with 8, and if I did it using 8, this is one where we would just have to do it twice. I get 8 times 40 under my root. Well, cube root of 8 is 2, so I would say 2 times the cube root of 40. I can break down 40 into the cube root of 8 times 5. Cube root of 8 is 2. We'd move that outside, so outside we'd have 2 times 2 times the cube root of 5. You're still going to get 4 times the cube root of 5. I just wanted to show you if we have to move multiple things out, we multiply on the outside. If you see 64, absolutely do that. Anything so far? So we can do cube roots with numbers. We now need to do cube roots with variables, kind of like we did our square roots of variables. One moment. Show the page, please. Cube roots with variables. Zoom in a little more here. Cube root of x cubed is like me asking you what times itself is x cubed, and don't overthink. X, of course. The cube root, though, of x to the 6th is like me asking you what cubed gives us x to the 6th. X squared, because you know that a power to a power, we multiply those. So the cube root of x to the 6th is x squared. What is your shortcut that you're really just doing to the power? I'm doing some division here. With our square roots, we divided by 2. Well, with cube roots, we're dividing by? Well, that should make a whole lot of sense, dividing by 3. So over here, we're going to get the cube root of, okay, x to the, oh, no, whoa, totally wrong, sorry. Cube root of x to the 12th is x to the 4th, because we're dividing the power by 3. Y to the 15th? Y cubed. We're going to pretend you didn't say that. Y to the 5th, and z to the 6th. To take the cube root of a variable whose power is a multiple of 3, all we do is divide the power by 3. Just divide the power by 3. But remember, when we had our square roots, we couldn't divide all the powers by 2. We had to do some rewriting with some of them. And that's what I'm going to do with these. Divide 4 by 3, you get 4/3. No fraction powers, not till January. We want to do some simplifying with this so we can handle this. Well, if my power is not a multiple of 3, I want to rewrite it as x to a multiple of 3 times x to whatever is left over. Well, the multiple of 3, that's just less than 4, is 3. I can say x to the 4th is really x to the 3rd times x to the 1st. Because, right, 3 plus 1 gives you 4. When you multiply, you add them. One of these things I can take the cube root of. I can take the cube root of x to the 3rd. What is the cube root of x to the 3rd? You are going to get x times the cube root of x. In the next one, the cube root of x to the 11th. 11 is not a multiple of 3. I'm going to rewrite this as x to the, what multiple of 3 is less than 11? 9. What's left over? X to the 2nd. And this is a little different than our square roots, because the square roots, the only thing left over was x. Here we could have x left over, or we could have x squared left over. Cube root of x to the 9th is x to the 3rd. So we're going to say x to the 3rd times the cube root of x squared. It's just a square root symbol with a 3 inside. To take the cube root of a variable whose power is not a multiple of 3, we are going to rewrite as a how about we just say rewrite as x to a multiple of 3 times x to whatever the leftovers are. And I kind of think that'll be enough to remind you what we just did over there. If my power is not a multiple of 3, I'm going to rewrite it as x2, a multiple of 3 times x to the leftovers, and then do the square root of the part that I can't. I'm not going to write that. We just kind of know that that's what's going on. I want to get you started with A, and then you're going to go do B. Letter A is going to become the cube root of. Was x to the 5th already good? No. I need a multiple of 3 here. 3. I'm going to say x cubed times x squared, and I am going to underline the x cubed just to remind me I can do more with that later. Keyshawn, what about y to the 7th? Is it already good? How are you going to rewrite it? Okay, so I need a multiple of 3 that is less than 7. What multiple of 3 is less than 7? 6. We're going to say y to the 6th, and what's left over? 1, y to the 1st. I can handle y to the 6th. I'll deal with that in a moment. Jamie, what about z to the 25th? Is it good or does it need rewriting? How? Good. Z to the 24th times z. I'm going to go and take my cube roots. So I'm going to get just an x, just a y squared, and a z to the 8th, I think. Okay, 8th. Cube root of x squared y z. You do the next one. You do need the cube because you know I'm going to take off a point if you don't. Really, really, really quickly sign out. Try letter B, please. By the way, tonight with the homework and really all the time with this stuff, I'm going to need to see the breaking down work. I've got to see that first line before you give me the answer. I will be looking for that or you will not get full credit for the homework. Daniel, what did you do to 8 to the 50th? 8 to the 48th times a squared. Abby Amershek, how about b to the 21st? It's already good, so we're just going to leave that. I'm just going to rewrite it for right now. So since you didn't do any work there, how about telling me about the c's? C to the 42nd, C, good. And Abby Deaver, how about D? Good. Again, I'm going to need to see work in the homework. This is the line of work I need. Not bad. Then we're going to go and we're going to take our cube roots. I think that's going to be a to the 16. 16? Okay. B to the 7. C to the, help me out, not 13, 14. D to the 33. And inside our root, we're left with an a squared, a c, and a d squared. Not terrible here. Now we need to put these things together. I don't totally know why I left this box in here for the basic idea. I guess we can write the basic idea. Ready for this? We use the number rules on the numbers. We use the variable rules. You know what? We don't even have to bother writing that. We can just cross this out. Oh, well, you need to go clean that up.
Tell me it's the app. I'm so pissed off right now. I'm so sad. Okay.
Cross out basic idea. Use the number rules on the numbers. Use the variable rules on the variables. Whatever. Let's take a look. I want to start B together because I think that's a tiny bit harder than A. Then you're going to finish B. You're going to do A. Then we'll move on to other types of roots. Letter B. I want to try to rewrite this. I'm going to say the cube root of. Question number 1. Are you going to start this by pulling out an I because of that negative? We have i's for square roots. We don't have i's for cube roots. What I mean by this is I need to find a perfect square that I can divide 464 by, and let's make that a negative perfect square. So like negative 8, negative 27, negative 64. I have things that I need to be doing. No. Well, because A is easier, I want to get you started in B, and then you're going to do A. I think maybe we just shouldn't have spilled our drink all over. What negative perfect cube is inside 464? You have plenty of energy. What perfect cube? 8. And why don't we, instead of 8, use negative 8? Because I can handle the cube root of that. Negative 8 times 58. And then, you know what? I want you to do the rest. Break down your variables. You can handle that. And then go back and do letter A. We haven't really done anything new. Yes. Yes. Remember, for the numbers, we're looking for those cubes, the 8, 27, 64, 125. But for the variables, you want multiples of 3 for your power. Break them down and simplify.
Wait, will the 2 be negative outside?
It will be negative 2. And again, when you're done with B, go back and do letter A as well. We will go through it in a moment. Again, when you are done, go back and do letter A. I think letter B should be negative 2. X to the 3rd, y to the 9th, z to the 11th, times the cube root of 58, x, z, I think. No y's left in there. Just be on the lookout. Negative inside, negative outside. Keep going with A, and in a moment I'll have some people help break that one down for me. Yes, thank goodness.
Mr. Lickser, cross clock idle.
was very good. Okay, time to do letter A. Josh, what did you do? What did you do with 625, Josh? 125 times 5. I like that. I'm going to underline 125. I'm not going to call on anyone for x. X cubed was already good. Courtney, what about y to the 17th? Just didn't hear the end. Shh. Excuse me. Excuse me. I would like to hear Courtney. Thank you. Y to the 2nd. Okay, you're still talking, and I need you to stop talking. Not right now. Not right now. Y to the 15th, y squared. Ariana, tell me about the z. Good. Z to the 102nd and z cubed? Squared. Okay, so this is going to be 5. X, y to the 5th, z to the, help me out, z to the 34, okay. And inside, don't forget your cube root symbol, the cube root of 5, y squared, z squared. Anything with cube roots? This is half of what your homework is for tonight. I am going to hold on for 2 seconds because it's going to stop if I don't stop it.